Chapter 9, Neural Networks and Deep Learning. Deep learning is a family of machine learning methods based on learning data representations. So it is based on feature learning. Let's go to section 9.1, Basics for Deep Learning. Conventional machine learning is not easy to get good classification model using raw data. So engineers should provide features. For example, this autobike image is raw data, and engineers make features, and along with that feature representation, now machine learning algorithm work to get classification model. So here, coming up with features is difficult and time-consuming and requiring expert knowledge. Also, before and during learning, the features must be tuned, so we have to spend a lot of time. Here we have examples of features, histogram of oriented gradients, and the scale invariant feature transform shift. On the other hand, in representation learning, the representations, features will be discovered automatically. So we can feed the machine learning algorithm with raw data. Deep learning methods are representation learning methods with multiple levels of representation and abstraction. Each level, each layer, simple operations will be given, and along with multiple layers, and it can be a higher and abstract representation. Here are key aspects for representation learning. Layers of features are not designed by human engineers. These are made automatically. And these algorithms will learn features from data using a general purpose learning procedure, which means that you don't have to be very complicated and you don't need very complicated implementation. Just a general purpose learning method is enough. Here we have advances in deep learning, image recognition, speech recognition, and natural language understanding. These are basically image-based processing. Speech is a signal. However, when you the processing this data, it will be transformed using here Fourier transform, so that the result will be like two-dimensional data. So that along with a short time Fourier transformation, and locally it becomes image, so that the speech recognition is like image-based recognition. And among these examples, we consider question answering machine from IBM, and IBM Watson in 2011 defeated legendary Jeopardy champions and winning the first prize of $1 million. And also many other domains, these algorithms are used and being developed. Here, deep learning has provided breakthrough results in speech recognition and image classification. So it is image-based classification. It is working super. Okay. What about deep learning? Why is it generally better than other methods on image, speech, and some other types of data? Here, short answers are, okay, deep learning means using a neural network with several layers of nodes between input and output. So it is a multi-layer setting. Of course, multi-layer neural network was it's not new. It has history more than 30 years. But here, and earlier, and with one hidden layer, it was working well. However, even though you add more hidden layers, it is not really improving. And along with some new techniques, now multi-layer network improves the accuracy. So new things are added to use multi-layer networks. And also, here, series of layers between input and output and do feature identification and processing, and just as our brains seem to do. So multi-layer with now future processing together makes deep learning way better than the conventional methods. And of course here, multi-layer is known from a long time ago, and some new techniques are added. But these new techniques are not really big techniques. Small new techniques adjust the known techniques, and along with well combination, deep learning become very powerful. Here we have terms AI, machine learning, and deep learning. Artificial intelligence is intelligence exhibited by machines. And machine learning is an approach to achieve AI. And deep learning is a technique for implementing machine learning. Here we have some components: future representation learning, multi-layer neural networks, and backpropagation, and some of small new ideas. And also here, backpropagation is known also from a long time ago. However, earlier it was not really well working, except for some special examples. But later on, from 2006, it is revised, and then it started working very wonderfully. Backpropagation to train multi-layer architectures. Backpropagation is nothing more than a practical application of the chain rule for derivatives, particularly for gradients. And however, because of poor local minima issue, it was ignored. And here in 2006, it is revived along with some revised format. And particularly in CFAR, Canadian Institute for Advanced Research, and researchers in CFAR made wonderful progress. And here, along with that new algorithm, and it is applied for hand-written digits and detection of pedestrians, and also using GPU, they speed up the algorithm for speech recognition about 10 to 20 times faster. And along with a new form of machine learning algorithm, local minima become rarely a problem. Here also quite recognizable uses the convolutional neural network, and also these convolutional neural networks are known from a long time ago. But anyway, it is overall some new, small new techniques and good combination makes a really wonderful algorithm. Also, a part of the new algorithm is activation functions. And activation is not only limiting values, but also adding some nonlinearity. Here, example of activation functions are here. That is called rectified linear unit and hyperbolic tangent function, and this is a sigmoid function. Here, we have machine learning challenges to overcome. And the first one is interpretability, and second one is one-shot learning. Although machine learning has come very far, researchers still don't know exactly how deep trained net work. If we don't know how training nets actually work, how do we make any real progress? And along with this question here, interpretability is really important. If you know, if you understand the algorithm, then you can more easily modify and you can make a good progress. So interpretability is very important. Another one here, one-shot learning, is basically we want to train a classification model along with just a few data points. And traditional networks need a huge amount of data and are often in the form of extensive iterative training. But instead, and we should find a way to enable networks to learn using just a few examples. Here, one-shot learning is representing this concern. And current neural networks are gradient and iteration based. Can we modify or replace it? That's the ultimate question. And if you can answer this question, then you'll be rich anyway. It's a really important problem. And human being can understand the object or scene through a few examples. However, these machine learning algorithms needs huge amount of data. And however, when you start working on some new data set, then in the beginning, number of data points is not really large. So that for small size data set, if some algorithm is working very well, then it'll be really useful. So that's the reason one-shot learning is very important challenge for human society. Okay, this is end of the section. Thank you.